In this example, we're going to compare decimals using inequality symbols. So inequality symbols are the notation we're going to use to compare them. So it's just two numbers instead of the ordered list we were using before. So let's look at the first example. So we have 0.53 or 53 hundredths, 62 hundredths. So I'm going to look at these, looking at the tens place. Okay, so they're both 0 and the 1s. The tens place, this is a 5, this is a 6, so this number is larger. So the open part of the inequality sign will go towards 0.62. Let's look at the next one. Well, here they're both negative, so let's think about their absolute values first. 0.01 and 0.09. Well, they have the same 1s and 10s place. 1 is smaller than 9, so 0.01 is less than 0.09. But when we have negatives, we take the opposite. So negative 0.01 is greater than negative 0.09. Another way to think of this, you can think of this as owing money. Owing 1 cent, so 0.01 is like a penny. That's better or greater than owing 9 cents. Now, I like this one because I don't have to do too much thinking. I don't even have to look at the place value. So take a second and see if you can see why. This number is negative, this number is positive. A negative number is always less than a positive number. Okay, so don't get too wrapped up in the place value part when the signs are opposite to begin with. Okay. Here, the same idea. 5.67 may be larger than 3.42, but it's negative, so this is definitely the smaller number. Now we have negative 2.4 and negative 1.7. Let's look at their absolute values. So 2.4 and 1.7. Well, 2 is more than 1, so we know that 2.4 is greater than 1.7. which means negative 2.4 is less than negative 1.7. And finally, another easy one. This is negative, this is positive. So notice we think of this as a small number. This is like 3 cents if you wanted to think of this in terms of money. But this number is greater than this number because this is like owing $6.17 because it's negative. So I'd rather have 3 cents than to owe $6.17. So the positive number is greater. And we're done.